Okay, this will be the first video for Bryan Triple Flex quiz number 3. This should be the last quiz for the Bryan Triple Flex. We'll move on to something different next week. I want to start with the diagram, page 1, and kind of go over where we're at right now. We've got to the point where we turn the control power switch on. Over on page 2, we had the stat input, which was the 24 volt relay. We were able to figure out how to get the stat input on. And when the stat input goes on, it actually tells the combustion air fan and the flue exhaust fan to start through relay contacts that are built in here on terminal or connection J4. Terminal 2 and 3 and 4 and 5. And I want to go into a little more detail on that in just a second. But we get power down here to our proof of closure switch. We know the gas valve is in good shape. Our enable lamp is on. This relay makes because we have our stat input on. The power is on. And we went through in the last quiz and set of videos, we talked about the safety circuit. Here was the terminal number 3 coming off of the control switch, comes down. Here's your low water cutoff, thermal fuse, gas pressure switches. And all of these switches you saw do run in a series. It goes from here to here to here. But off of each one of these, after each switch, it goes over to an annunciation pin or plug on the controller here. And I wanted to show you, if you go back to the main menu and open up the Bryan Triple Flex IOM, there's some screenshots on here of the touchscreen display. And I want to show you this part right here. You know, if you're wondering on all of those safeties, whether they're on or off, you know, you could get your meter out and you know you would be trying to measure 120 volts at the low water cutoff, and then on the output of the low water cutoff to the terminal that goes to the high burner temperature switch and then goes to the high gas pressure. But actually, all you have to do is go to the main screen, which looks like this. And right here where it says annunciation, you push that with your finger. It's a touchscreen display, and it will show you this annunciation page. And this pretty much tells you whether the low water cutoff is on or off. The high burner temperature is on or off. So if these are on, then you know that switch is closed. If you get to this point and it says there is high gas pressure is okay, but low gas pressure is off, then you would know that you probably need to reset the low gas pressure switch. It's a lot easier than getting out a meter and going through the wiring diagram and trying to figure out where you should and shouldn't have power. You just look at the annunciation page and it pretty much tells you where to look for a problem. So we got to that point, and finally the last thing in the series was the airflow switch right here that comes over to the airflow interlock. So all of the safeties are made. If we have the stat input on the low voltage relay that we showed, and I'll get to that on the terminology page here in just a second. But as you follow from terminal number 3, which is after your control power switch, it comes down. That's where it goes to the low water cutoff and begins the safety circuit series of switches. And it comes down here at terminal number 3, comes over to FS4-3 flow switch. This is probably the most common flow switch in the world. And I want to look at that on the terminology page. So if you open up Bryan TF terminology and scroll to the bottom, here is a picture of a McDonnell-Miller FS4-3. It's a typical flow switch box here with a knockout. You have your control wire goes through there. Here are the different paddles, the screw and the washer. The paddle attaches right here, and of course the paddle has to reach inside the pipe but not touch anything because you don't want to get stuck on anything. And here is how the switch is actually made. One thing I want to warn you is if you've ever tried to test a flow switch and you think just sticking your finger in here where the little bellows is and pushing it back and forth to make the micro switch make and break is testing the flow switch, that does not test the flow switch. That just means that the micro switch is functional. You really, in order to test a flow switch, you need to stop flow, and then you need to restart the flow, and you need to make sure that the paddle actually physically moves the bellows. This little tab here pushes on the switch. Just sticking your finger in there and pushing it back and forth and saying, yeah, it's good, is not testing it, because the paddle could have fallen off. The paddle could be stuck. You pushing on it, manually forcing it to make and break is not testing the switch. So really you should be stopping and starting the pump or opening and closing the valve to the boiler to make sure that the flow switch does work. That's how you would really want to test the flow switch. Getting back to this real quick, remember we installed a field installed demand relay for enable disable, and that was on the 24 volt. This is kind of important because when we get power on terminal number 3 here, after we close this relay, we get power from 19 to 20. 20 comes down to this terminal 3, which is called the stat input. Right here, stat input J83. When you get power to that stat input, that's when these contacts between J4, 2, and 3, J4, terminal 4 and 5 close, and it turns on the combustion air damper, it turns on the booster fan, and then you come down here. Of course, once the flow switch makes, we get power to terminal number 7. Terminal number 7 comes over here to the flow switch annunciation, which is this is the input that gets power, and then on the annunciation page it says yes, the flow switch is made. But then off of terminal number 7, it also goes up to the interlock for the flue exhaust booster and the combustion air damper motor or combustion air damper actuator end switch. So not only do we signal the fan and the combustion air damper to start here, we tell it to go, we have to prove that it went, which is from power on terminal 7 after the flow switch makes up to terminal 5. If we had any other auxiliary interlocks we needed to use, we could put those between 5 and 6. But once we get power here on 6, 120 volts, comes over to the boiler enable LCI. And I want to show you on the page, I'll have to figure out remember which one it was, but the terminal designation for J6 terminal 3, it is boiler enable, and it's limit control input, I think. And I'm going to make this a quiz question because I keep forgetting what LCI actually stands for. But that's where you finally get the signal that tells the boiler to go ahead and go through the ignition sequence. The blower is running, the pump is on, all of the safety controls are closed, the damper is open, the flue exhaust is on. All these things are proven, and it's time to light the pilot and then let the main gas valve open. Okay, so I went to the Honeywell R7910 Sola hydronic controller. This in your menu here, it's right here. It's the R7910 Sola Flame Safeguard. In the list of connector and terminal designations, I wanted to make sure you saw here where J63 is called load/limit control input. And I want to make sure you know that, and I'll probably put that on a quiz question. I want you to answer limit control input LCI, because a lot of times when you're looking at the display on these touchscreen displays on these boilers, there's going to be initials like that. And if you don't know what that initial means, it's going to be very confusing as to why it's not running. But limit control input J63, if you don't have power on J63, then something in the limit circuit is holding it out, and you just need to know what those initials stand for. So Getting back to the